Before the introduction of the task class, the ThreadPool class offered the best way to work with large numbers of threads. The great disadvantage of the ThreadPool class is that it's very difficult to tell when the threads have finished. The task class improves on the ThreadPool class, but you may still see ThreadPool being used in older projects. To begin this lesson, open the Mathland project from your Sample Files folder. And open the code behind file of primes.aspx if it isn't open already. Now remove the existing threading code. That's everything from thread 1 to the end of the while loop. You're going to replace this code using the ThreadPool class. Add the following code in the space that the code you removed previously occupied. ThreadPool dot queueUserWorkItem new wait callback calculate primes new int 2 maximum value divided by 4. This code queues up a task using the ThreadPool class. The ThreadPool class will automatically allocate this task to a thread and execute it. Otherwise, this code is very similar to the code that you used for the thread class. This time you're dividing maximum value by 4 because you're going to use 4 threads, each one doing a quarter of the work. Now add the following code to allocate the other 3 tasks. ThreadPool.queueUserWorkItem new wait callback calculate primes new int maximum value divided by 4 plus 1 maximum value divided by 4 multiplied by 2. ThreadPool.queueUserWorkItem new wait callback calculate primes new int maximum value divided by 4 multiplied by 2 plus 1 maximum value divided by 4 multiplied by 3. ThreadPool.queueUserWorkItem new wait callback calculate primes new int maximum value divided by 4 multiplied by 3 plus 1 maximum value. All 4 threads are now allocated. The only problem is that this code introduces a race condition, and you don't have any way of knowing when the tasks are complete. The ThreadPool class doesn't provide any information on the status of your threads, so you will need to be a little more creative. Add a public property by adding the following code outside any event handlers. Public int threads completed equals 0. Now add the following code to the end of the calculate primes method. Threads completed plus plus. This means that the threads completed property will increase by 1 each time the calculate primes method is completed. When threads completed reaches a value of 4, you will know that all 4 threads have finished. Now add the following code to the button calculate primes click Event Handler, just after your ThreadPool code. While threads completed is less than 4, thread dot sleep 1000. This code will wait until threads completed reaches 4, waiting 1 second between checks. This will prevent a race condition. Test your code now by viewing primes.aspx in your browser. When the page appears, click Calculate Primes. This time you're using 4 threads to calculate the prime numbers. My computer has 4 processor cores, so this is faster for me. But it may not be any faster if you have only 1 or 2 processors. You might think that this code would run even faster if you divided the calculations between even more threads, but this is unlikely to be true. In general, you should only use as many threads as the computer has processors. If there are more threads than processors, your computer must divide tasks between the available processors. In extreme cases, this can be slower than using a single thread. To limit the number of threads that the ThreadPool class creates, you can call the ThreadPool.setMaxThreads method. You may wish to do this to limit the number of threads created by the ThreadPool class to the number of processors in the computer. Close your web browser now and close Visual Studio. You've now completed Lesson 3.7. Implement multithreading using the ThreadPool class.